In number 11, they want tangent of 60. Well, here's our 60, and it works this way. That's how our 30, 60, 90 triangle works. So tangent of 60 is opposite over adjacent. Tangent is opposite over adjacent. X root 3 over x. That's nice. Just reduces to root 3. That's it. Tangent is 60. That's opposite. X root 3 over x is just root 3. Okay, let's go on to 14 and 16. So 13, 14, 15, 16 are functions of 0, 90, 180, or 270. That's our unit circle. Unit circle means a circle with a radius of 1 unit. If this has a radius of 1, that's the center is 0, 0. What's that coordinate? 1, 0. If this has a radius of 1, it must be 0, 1. The radius is always a positive number, but the point, as we go left on the negative, that's a negative 1. And here we're at 0, negative 1. So these will give you your x's and y's, and r is always 1 no matter where you are, 0, 90, 180, or 270. So let's do sine 90 first. 90 degrees is here. So look at this point. Sine is y over r, which is 1 over 1, which is 1. So sine of 90 is 1. Cosecant 270. We're going to find sine 270 and then take the reciprocal. Sine 270. 270 is here. Sine is y over r, which is negative 1 over 1, which is negative 1. So sine of 270 is y over r, negative 1 over 1, which is negative 1. Cosecant is reciprocal. Reciprocal of negative 1 is still negative 1. You flip it over, it's 1 over negative 1, which is negative 1. All right, so that's those two. All right, number 18. We have the point negative 5, oops, it's negative 5, negative 12. We want to find a sine, cosine, tangent. So we could do this. Negative 5, negative 12, we're down here somewhere. And make this triangle. That's negative 5, that's negative 12. Aggregate it there, and we're going to get 13. So we can use that triangle, but we don't even have to because this is our x, this is our y. Let's solve for r. That's 25 plus 144, 169. So r is the square root of 169. Usually we'd say plus or minus, but r always has to be positive, and that's at 13. So you got that's all you need in order to form the trig function. So if we want sine of that angle, sine is y over r, negative 12 13. Cosine, x over r, negative 5 13. Sine is y over x, negative 12 over negative 5. Negative over negative be a positive 12 fifths. Easy enough. That was number 18. One more. Number 20. Okay. Personally, I think the only one that can cause you any agita at all is 19 and 20. And after you see this, they're not so bad. But up to now, is there anything too difficult? I think you're going to be good. But let's look at number 20. This is saying if cotangent of some angle equals square root of 2 and the sine of that same angle is greater than 0, then they want us to find cosine. Well, the information we need to get here is our x, y, r, and also what quadrant we're in. So I'll say that again. We need to know x and y and r, and also what quadrant we're in. I'm going to do the quadrant first. Okay, cotangent is a positive number. Don't know much about cotangent except it's reciprocal of tangent. Well, if cotangent is positive, its reciprocal is also positive. I'm not worried about the square root of 2 yet. I'm just doing the positive negative thing. If cotangent is positive, its reciprocal has to be positive. Okay, so we have tangent positive. At the same time, we have sine is greater than 0. So sine is positive. So we're going to find out which of our 4 quadrants is both tangent positive and sine positive. Well, remember this? All sin tan cos. All sin tan cos. All sin tan cos tells us in what quadrants a function is positive. Okay, so they're all positive here. Only sine is positive there. Only tangent is positive there, and only cosine is positive there. I'm not talking about the reciprocals. It's just sine, cosine, tangent. All right. So where is tangent positive? Well, they're all positive there, so tangent's positive there. Is tangent positive here? No, only sine's positive there, so tangent can't be. Is tangent positive here? Yeah, it says it is. So we're there. Is tangent positive here? No, only cosine is, so tangent can't be. So far we have quadrants 1 and 3. Now where is sine positive? Is sine positive here? Yeah, they all are. Is sine positive here? Yeah, it says it is. Is sine positive here? No, only tangent is, so sine's not. Is sine positive here? No, only cosine is. So which one does it double check? Here we are. So after all that, we're in quadrant 1. Okay. So if we're in quadrant 1, what does that mean? In quadrant 1, x is positive, y is positive. Of course, r is positive in every quadrant. Here's what we got. In quadrant 1, any point in quadrant 1, it's a positive x, positive y, right? You got a point like 3, 7, positive x, positive y. All right, so we don't need it anymore. Now that we know x, y, and r are positive, let's figure out x, y, and r. Okay, if cotangent is this, then tangent would be that. If cotangent is root 2, tangent is reciprocal. And tangent is y over x. That means y is 1 and x is root 2. And we already know that that's definitely a positive 1 and definitely positive root 2. We'll find r by Pythagorean theorem. So that's root 2 squared plus 1 squared equals r squared. That's 2 plus 1, so 3 equals r squared. R is going to be the square root of 3. Normally we think plus or minus, but r is always going to be positive. So now that we have this, what's cosine? Cosine is x over r, which is root 2 over root 3, which is root 6 over 3. Final answer, final problem. So pause this, rewind it. If you see this before we do our actual review in class, be ready with some questions on the odds.